So my name's Carl. I'm a product manager at Bio-Rad, and I'm going to be talking about two different things today. The first one is going to be MICE and the MICE guidelines. I don't know how many of you are familiar with it. You should become familiar with it if you're not, because I think it's going to be really important. It's going to be something that's going to be adopted in the near future. So I'm going to start off talking about MICE, and then I'm going to go into high-resolution melting analysis afterwards. So there's actually two handouts there you should have. One that's going to talk about the MICE guidelines and just a tech note that we've produced at Bio-Rad, and then another one for HRM talking about our precision melt software. But I'm going to start off with MICE, and as you can tell from the title here, MICE stands for Minimum Information for Publication of Quantitative Real-Time PCR Experiments. It's kind of a mouthful. It sounds like most of you are actually doing qPCR in your lab, so this is something that is actually applicable to pretty much everyone here. How many have actually heard about MICE? Just a show of hands. Oh, okay, so. And how many are actually going by the guidelines and are going through the checklist? Not too many just yet. And that is the case that, in speaking with people, not many people have started adopting this, although there is a big push by some of the leaders in the area for qPCR to try to get this out there, to try to get it accepted by people, and to get more people using it. Oops. So why is MICE needed? One of the reasons is that, as many of you know, there have been an explosion in the last decade or so of qPCR papers. It's been roughly, actually over 40,000 papers that have been published up until last year in the biomedical research area. So that's a vast amount of information out there. Unfortunately, up to this point, there have not been any specific guidelines or standards that people have traditionally been using to follow. And what this means is that there are a lot of variable results out there. And there has been great difficulty by a number of people to actually reproduce some of the data that's already been published. So it's difficult to compare one publication to another. Sometimes it can be difficult for people who are reviewing papers to understand precisely what they're doing and to understand why the results they're seeing are so different from other researchers. So it's difficult to make comparisons. And another consequence, an unfortunate consequence, is that there has been some bad data that has been published. And there have been some significant consequences and some subsequent retractions, as you can see here. And I'm going to give you just a few quick examples of that, just to emphasize the point of why MICE is actually needed and why people should be adopting this and following it in every lab. This is a paper that was published in AIDS Research and Human Retroviruses in 2006. And for the most part, there's not really anything at this point that's too worrisome. But if you look here, if you just zoom in the very first figure, some of the data, they actually quote slopes. And you see that the slope that's listed there is minus 2.276. Most people can't do that math in their head to convert it to efficiency, so we've done it for you. And when you do convert it, you see that it's 175. And Frank's talk earlier, he pointed out that typically you want to get into a more optimal range between 90 and 110, 90, 105, around that range. And this is way above that. So there's definitely problems with this data. And you can see here's another example. The same figure, 440%. Now that really never should have been accepted, but it was. It was published in a respected journal.